How much water flows through the vadose zone? It's a critical question for soil scientists, irrigators, ecologists, hydrologists, anyone who works in the soil-plant atmosphere continuum. Intuitively, you might think you could measure this by putting some type of collector in the ground and then emptying it to find out how much water was moving downward. This is the theory behind the panlysimeter. But panlysimeters don't accurately measure the amount of water moving down through the soil, and here's why. When you install a panlysimeter in the soil, it creates this boundary layer that is under zero tension. In unsaturated conditions, the water in the soil is being held under tension. Water flow through soil is from areas of low tension to high tension. Because of this, water physically cannot flow into the panlysimeter and instead will flow around the panlysimeter. This flow divergence greatly reduces the accuracy of a panlysimeter. With a passive capillary lysimeter, like the drain gauge G3, the boundary layer is overcome with two innovative solutions. With the addition of a divergence control tube, or DCT, the amount of divergence from the drain gauge G3 is greatly reduced. The DCT creates a barrier that traps the water coming through the soil and prevents it from going around the drain gauge G3. Additionally, an inert fiberglass wick is used to apply a set tension by creating a hanging water column. The tension applied by the wick helps overcome the boundary layer effect by mimicking the tension that the soil would typically apply and pulling the water into the measurement reservoir. The DCT extends the tension that the wick is applying through the soil to the top of the DCT. The combination of the DCT and the wick vastly improves the collection efficiency of the drain gauge G3. For more information about measuring deep drainage, contact an application scientist. Or you can also find more information on our website at www.decagon.com.